The natural world is home to a vast range of creatures, but few evoke a sense of both awe and ancient mystery, quite like the crocodile. With their rugged skin, stealthy movements, and piercing eyes, crocodiles appear as though they belong to a time long before humans. Because they do. The crocodile lineage dates back over 200 million years, placing them among the most ancient reptiles on the planet. These creatures have survived mass extinctions, shifting continents, climate changes, and the rise and fall of empires. They are more than just impressive predators, they are living fossils. In this comprehensive deep dive, we will explore the evidence behind their ancient origins, how crocodiles have evolved and adapted through time, their relationship to dinosaurs and birds, and the reasons for their incredible longevity as a species. The story of crocodiles begins during the late Triassic period, around 230 million years ago. During this time, the Earth was a very different place. The continents were joined into a supercontinent known as Pangaea, and the first dinosaurs were beginning to appear. The earliest ancestors of modern crocodiles belonged to a group called crocodilomorphs. These creatures were not the swamp-dwelling ambush predators we recognize today. Instead, they were often terrestrial, slender, and nimble creatures, walking on long legs and probably hunting small prey on land. Some early crocodilomorphs, such as Terrestrasuchus, had features more similar to small carnivorous dinosaurs than to modern crocodiles. These early crocodilians shared the Earth with the dinosaurs, and unlike their modern relatives, were often more active and agile. The fact that crocodiles began evolving so early in Earth's history, at the same time as some of the first dinosaurs, explains why they are sometimes referred to as archosaurs, a group that also includes dinosaurs and pterosaurs. By the Jurassic period, approximately 200 to 145 million years ago, the ancestors of crocodiles began to diversify into a range of different ecological roles. Some remained terrestrial, while others began adapting to aquatic environments. One of the most striking adaptations of this period was seen in a group of crocodilomorphs called thalattosuchians. These were marine crocodiles that looked more like dolphins or ichthyosaurs than modern crocs. They had long, streamlined bodies, paddle-like limbs, and tails adapted for swimming. Species like Metriorhynchus lived in the open ocean and likely preyed on fish and other marine animals. Some were even capable of giving birth to live young in the water, a rare trait among reptiles. These ancient marine crocodilians showcase the flexibility of the crocodilian body plan. They could adapt to land, freshwater, or oceanic environments, depending on ecological needs. The Cretaceous period, 145 to 66 million years ago, saw an even greater diversification of crocodilian ancestors. Some of these ancient species were truly monstrous in size and power. For example, Sarcosuchus imperator, also known as the supercroc, this prehistoric crocodile lived around 112 million years ago and could grow over 40 feet, 12 meters, in length. It likely preyed upon large fish and possibly even dinosaurs. Deinosuchus, living in North America during the late Cretaceous, Deinosuchus could reach lengths of 33 feet, 10 meters, and had a bite force powerful enough to crush bone and shell. These enormous crocodilians likely filled ecological niches, similar to apex predators today, competing with the likes of tyrannosaurs and other massive carnivorous dinosaurs. Fossil evidence has even shown dinosaur bones with bite marks matching crocodilian teeth, suggesting direct predation or scavenging. Despite their fearsome size, not all crocodilians of the Cretaceous were giants. Many smaller, semi-aquatic, or even herbivorous species also existed, highlighting their evolutionary versatility. Perhaps the most astonishing part of the crocodilian story is how they survived the Cretaceous-Paleogene KPG extinction event about 66 million years ago, the same event that wiped out the non-avian dinosaurs. This extinction, believed to have been caused by a massive asteroid impact and subsequent global climate disruption, led to the disappearance of about 75% of Earth's species. Most large terrestrial animals perished, along with marine reptiles, pterosaurs, and many forms of early mammals and birds. But the crocodiles lived on. Why? Several factors contributed to their survival. Aquatic lifestyle. Being semi-aquatic, crocodiles could find shelter and food in freshwater systems less affected by global devastation. Opportunistic diet. Crocodiles are not picky eaters. Their ability to scavenge and consume a wide range of food likely helped them through times of scarcity. Low metabolism. Crocodiles can go weeks or months without eating, a key trait during periods of famine or ecological collapse. Burrowing and dormancy. Some crocodilian species burrow into mud and enter states similar to hibernation, protecting them from harsh environmental changes. Their survival through one of Earth's greatest extinction events highlights their remarkable resilience and biological efficiency. It may surprise many to learn that crocodiles are more closely related to birds than to any other reptiles alive today. This is because both belong to the Archosaur clade, and more specifically, to a subgroup called Archosauria. This connection is backed by fossil evidence and modern molecular studies. For example, birds and crocodilians are the only living groups that have a four-chambered heart, similar lung structures, and certain reproductive traits like laying eggs with hard shells. Additionally, studies of crocodilian embryonic development have revealed genetic and anatomical similarities to bird embryos, especially in skull and limb development. This link has made crocodilians a crucial subject in evolutionary biology when studying the transition from reptiles to birds. One of the most iconic features of crocodiles is their unchanged appearance. Compared to their ancient ancestors, modern crocodiles look strikingly similar: rough skin, long jaws, and a low-slung body. This phenomenon is known as evolutionary stasis. But what causes a species to remain relatively unchanged for millions of years? Some key reasons include ecological efficiency. Crocodiles are incredibly effective predators. Their physiology allows them to thrive in aquatic ambush roles with minimal energy expenditure. Stable niches. The freshwater ecosystems where crocodiles typically live have remained relatively consistent over geological time, reducing the need for drastic evolutionary shifts. Developmental constraints. The crocodilian body plan is robust, and significant changes might reduce their survival rather than enhance it. While it's not accurate to say crocodiles haven't evolved, genetically they have, their morphological adaptations have remained largely consistent because they simply work so well. One of the most iconic features of crocodiles is their unchanged appearance. Compared to their ancient ancestors, modern crocodiles look strikingly similar: rough skin, long jaws, and a low-slung body. This phenomenon is known as evolutionary stasis. But what causes a species to remain relatively unchanged for millions of years? Some key reasons include ecological efficiency. Crocodiles are incredibly effective predators. Their physiology allows them to thrive in aquatic ambush roles with minimal energy expenditure. Stable niches. The freshwater ecosystems where crocodiles typically live have remained relatively consistent over geological time, reducing the need for drastic evolutionary shifts. Developmental constraints. The crocodilian body plan is robust, and significant changes might reduce their survival rather than enhance it. While it's not accurate to say crocodiles haven't evolved, Genetically, they have. Their morphological adaptations have remained largely consistent because they simply work so well. Today, the order Crocodilia includes three major families: Crocodilidae, true crocodiles, e.g., Nile crocodile, saltwater crocodile; Alligatoridae, alligators and caimans, e.g., American alligator; Gavialidae, gharials and false gharials, e.g., Indian gharial. There are roughly 24 extant species, spread across the tropics and subtropics of Africa, Asia, the Americas, and Australia. The most well-known species include saltwater crocodile, Crocodilus porosus, the largest living crocodilian, capable of growing over 20 feet, and found from India to northern Australia; Nile crocodile, Crocodilus niloticus, Africa's top freshwater predator; American alligator, Alligator mississippiensis, a conservation success story, once endangered but now thriving in the southeastern U.S.; gharial, Gavialis gangeticus, a fish-eating specialist with a long, narrow snout, now critically endangered in parts of India and Nepal. Each species is adapted to its particular habitat, but still retains the core traits that have served crocodilians well for over 200 million years. Our understanding of crocodilian history comes largely from the fossil record. Crocodilian fossils have been found on every continent except Antarctica, revealing a wide range of extinct forms, from burrowing desert dwellers to ocean-swimming giants. Some notable fossil discoveries include Stomatosuchus, a bizarre duck-billed crocodile with a soft pouch under its jaw; boar croc, a land-based predator with boar-like tusks discovered in Niger; Anatosuchus, a small herbivorous crocodile that may have fed on plants and insects. These fossils demonstrate that crocodilians were far more diverse in the past than they are today, highlighting their adaptability and evolutionary success. Despite their incredible evolutionary legacy, many crocodilian species today face serious threats from habitat destruction, pollution, climate change, poaching, and illegal trade. Species like the Philippine crocodile and Chinese alligator are critically endangered, with only a few hundred individuals remaining in the wild. However, conservation programs, captive breeding efforts, and legal protections have helped some populations recover. For example, the American alligator went from near extinction in the 20th century to stable numbers today. Preserving crocodiles isn't just about saving individual species, it's about maintaining a living connection to the ancient Earth, a world where dinosaurs roamed and continents drifted. Crocodiles have persisted through volcanic eruptions, ice ages, asteroid impacts, and the rise of humankind. Their 200-million-year journey is a testament to biological efficiency, resilience, and evolutionary brilliance. While the world around them changed dramatically from dinosaurs to smartphones, crocodiles remained. To study crocodiles is to glimpse deep time. They are not merely predators of rivers and swamps, they are survivors of epochs. As we look to the future of conservation and biology, crocodiles remind us of the importance of preserving not just biodiversity, but also evolutionary history. In every snarl, splash, and stealthy lunge, they carry with them the echoes of a primordial Earth.